Hi, this is Richard Collins with the Internet Foundation, and this is part of just my background education, trying to get familiar with the issues in building and re-engineering all of the equations on the Internet. I'm reading an article here on the Stark effect. I just picked a simple example here. This is a common sort of thing. This kind of page occurs all over the Internet, probably hundreds of millions of times. And the context is that you have an equation, a mathematical equation, usually, various special symbols that are hard to type usually. And in this case, like here, this on Wikipedia has been transferred into a image, so you can't actually do anything with it. A human can look at it, and that's it. That's pretty much the. I know that yes, I can go in and probably write a raster image to vector text. Machine vision kind of thingy, and pull the pieces out again. What would be better is just to establish a way for all people who are working with equations like this to share them in symbolic form that's universally agreed on. And because I'm the Internet Foundation, I'm going to set the rules, or I'm going to try to set them so they're fair for everybody. And hopefully, being an outsider, not no axe to grind for any particular group, I can sort of say, look, here are the ways forward. At least I can keep repeating the basics again. So anyway, that's one, and this was the one I chose a simple mixed thing. So it's when you see this sort of thing, you got Greek letters that somebody's going to do, integrals and differentiation and differential equations, that sort of thing. And then summations means that somebody's also worried about actually doing calculations with it. So this is our world now. So we have a sort of a continuous world. We do these sorts of things, but all the real work on this is done at a integer or discrete level. So just deal with it. So that's the thing I was looking at. So just kind of keep that. Let me pull this down a little bit and shrink it to this. There's a lot of things I'd like to do. Keeping little windows of things. Like here, it would be a lot easier if from that context, I could say, highlight it and just say, open this in a window, right? You just say, zoom on that and stick it out as a separate window so I can keep it. So now I've got all this wrapper, or the headers and all that other junk, this sidebar and that kind of stuff. What I'd really like to do is just keep it down to the bare minimum. So I'll just leave that for reference. Now, the program I'm working with is pretty crude. I'm just learning SVG today. I've seen it over the years. I've done so many of these things. I just hate having to remember it. So I've got the elements in the equation here. Let's see, where did it go? Okay, phi of r. So that's this one, phi of r. And why am I doing this? Because I want a variable in the programming language that I can stick things in. So the actual value, the double precision, actually in JavaScript, it's floating point, probably the equivalent of double precision. Anyway, I've got to deal with those issues too. But anyway, so in the programming language, I can assign it a value, and the value will be whatever it is there. So eventually you do this and you get a number out. Okay, so the value at the location, an estimate of the value at the location, depends on the location at the zero position, wherever that reference is. And then a series, these are distances out to various points out there where the F's, and I don't know, I'll deal with this later. Right now I just was getting the thing. So this is numbers for each. This is X, Y, and Z, I guess. So this is What a mess. Anyway, I didn't try to do more than just squeeze in and just replicate that. So I got, let's see if it matches it reasonably well. Let's see if, God, this is awful. Okay. All right, so there, how can I get, okay, up here. All right, so phi of r, and I had to write it that way. Shoot. Let's see, where did it go? No, 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 no. There it is. Okay. So phi of r thickness, thick approximation. What a weird name. But approximately equals is what I did. The reason was it got too doggone long. So there's the layout of this, the crazy, text editor we're still using after 50 or 60 years of programming. And we're still doing the same thing we had in Fortran. A text editor, you have to line things up yourself if you want to make it readable. Anyway, it's just a pain. So the phi zero term, and then the sum. Eventually, each of these have values, numerical values. The approximately equals, in a sense, does too, because the degree of error is a numeric thing. So I might throw it in there. Anyway, so there. So I've got, basically I didn't try to do everything. This one I put sigma r sub I. I tried putting a sub in there, okay, but I used an SVG, and SVG overrides the things, and it won't accept it. It basically took it, but it converted into HTML and threw it outside the text symbol. So I was trying to put this in a text symbol, and then it just failed. I won't show you. It just basically, it started it out. It did the sigma, and then I had r sub I, with a bracket sub, and then it just lost it. So, God, all these different groups can't even make, SVG can't even talk to HTML. I mean, I can probably negotiate some of these things, or I can help, unravel it. I don't, like I say, I'm just trying to get it all to work. And what am I doing? I'm not trying to get a particular solution out of here. I'm just trying to get people to, get in the habit of, if you're doing something, look around, find out who else is working on it, who's affected if you change anything. The worst problem on the internet is the programmers in these ivory tower, huge organizations, and they sit there and they never get out of their box and go and talk to the customers, the people who actually use it. And when you have 1 billion users of something, or a few tens of millions using something thousands of times, it has a huge impact on society as a whole. I count those things. 1 billion hours of human time, which is not really that big on the internet at all. It's a dink, okay? And that's about $32 billion, okay? I can put it in quantitative terms. Anyway, so I got that. So that's what I'm trying to do. So let me move this out of the screen so it won't disappear on me. Let me go to here. I wrote it in there. I've got it in a content script. I just updated the content script there. I had to be in localhost, so it won't throw all kinds of fits if I try to use my disk drive. Okay, and there. Okay, so now I got it. So the equation is phi of r is approximately equal to phi of 0 and poop, pardon me, there. So I lost my plus sign, or I don't have a plus sign. So I've got to go back and manually, where's my program? I've got to go approximately equals that. Oops. So I need one of these. Control C. R plus. I need a symbol on the parent. And I'm trying, this I can't even auto increment, so I'm just 300, 400, okay, that's there, and this is just going to be plus, Now, I may throw this out of I have a div of my own, I call it a box, because I didn't want all the trash that went with the name div in HTML. All of the commonly used ones get so bloated, overused. Everybody throws in and says, well, I want to add my stuff to it. So so now I've got these, they're going to lay out on the screen. I had to make this twice as wide because it didn't, do I have to automatically? Anyways, so now I save it. I've got all my source code done. Now I go to the extensions. I got to reload the extension. I go back to localhost. I reload that in my test area. I bring out the equation, and then I do it again. Phi of r is approximately equal to phi of 0 plus, there. I left all the things on there. The red is the sum of x sub I, or it's supposed to be an r. It's really hard. I don't have any easy way to change the sizes and all yet. Okay, so that's approximately there. Now, what's my plan? Okay, so my plan is that I'll get these laid out about like this, and then I'll have a button over here that says save. And what it'll be is the save of the layout. I'll probably have to add in a thing. Now these I made them absolute, so you see what I'm doing. I'm using the red and blue. The blue is my box, which is an HTML box, and the red is the SVG work area. Okay, so I'm just doing that. Now, can I ignore that, or could I leave it off? Probably after a while, but it does help to line them up, and maybe I need to stick in some kind of a snap or something to do those. I just leave them on for the moment, but ultimately I can't. If I turn all those off, I've got a more or less functional equation that a human can read. And now the problem is, how do I get it, to do it? Well, I could, let's look at my source code. Now, my brother writes, Cliff, he writes parsers and compilers and things like that. So, var equation is equal to, let's do, I always use, okay, phi r, let's see, phi of r, approximately equals, that's a symbol, okay, phi 0, heck, why not, plus sum, okay, sum. Now, that sounds, it seems kind of funky, right? But I just realized that that's true. Okay, I don't need to use for equation. Basically what I'm doing is I'm using the tag name for the symbol in there. So I didn't write phi of r equals phi, let's see, phi of 0 plus sum of r I. It's actually, this is probably an ri times f I. Okay, and then and then you had to do, what's the rest of it? You have to I equals 1, 3, that kind of crap. Pardon me, that kind of stuff. So this gets hard because then you have the stuff here. But I could, what I'm thinking, would be some way to to cut this down so that you're okay. Basically, where I can take these equations, the compiler would know these. Okay, so if I did this and say add symbol phi of r, okay, the reason I expose them like this is so I can assign it a name that the compiler will know, and then I can give the compiler, something like this, something like, there. and just say that's the, the way you parse it. It means, and then what do you do? It means plus sum. So the sum is actually, this. It's a subroutine. Okay, and inside there, it's going to be a multiplication of that and all. But the person reading this might want to not have to deal with the details, right? They might just say, look, just run that for me, okay? Do an approximation. Say, give me this approximate phi of r, which is going to be, I can plot it. It's r, so it's 3, x, y, and z. So it's actually 3 equations. So it's phi of x, phi of y, phi of z. So it has 3 in 3, and so it's going to change that. You should be able to go in and do that. Now, let me keep this short. I just wanted to get this down, that I can do a program which creates symbols which I can move around as I want. So I make a connection. This is what I sent back. I didn't do it yet, but I'm going to return box. Okay, so so the box there. Okay, so I'm going to save that. So in my program, phi of r is the box, right? And I could say things like phi r dot value, because it's an object, equals 43. It's going to be phi of r. It's going to be a x 0, y 0, z 0, something like that. Okay, that's actually phi 0. I'm not going to get too complicated here. Okay, so no, there's phi at that location. So x, y, z. Shoot, I don't know. I'm just trying to put the pieces together. But the idea is that it's in the programming language. Then I can attach anything to it. I can put data structures. I can say, here, run this. Go to this internet database. Go to this living. I do a bunch of stuff on live video now from YouTube and telescopes and webcams or traffic cams, that kind of thing. So. Microphones, live streams from, microphone arrays, 10,000 microphones scattered all over the place, or 100,000 cameras or stuff like that. We aren't quite there yet, but I think we're going to be in the middle of it. So now, ultimately, people like to do cute things, but this is a little bit busy and hard to read, okay? So I probably will do add symbol. The box was just to remind me there. Okay, so I can do that. And add symbol. Oops. And let's see, add symbol. And let's see, I used it here. So I have to, that's the only other place. All human memory here, just, cranking and going. Here, symbol, x, y, symbol, I changed that. So this one now to stay there. Okay, so save. So I save all of them. So now my hover, or, the add symbol thing is a little bit easier. My equation is a little bit there. I could do things like this. I tend to write things as clearly as I can. That's the thing. It would be nice to just increment, say, okay, you just did an add symbol and initial position. So it's just how much time do you have to do it? If I only do this once, it's a real pain. If there were like 100 million people going to use it, then I would love to have an organization to go say, here, you work out an automatic way to do this. But anyway, so I don't know what to do in here. But the idea is that, this is just a listing. Okay, so this is just saying make an equivalence between this name and a symbol that you can manipulate, and then in a different context over here, I've manipulated this symbol, and presumably I can put a tag in there to get back to the context in the thing and say this is a symbol from here. Now, Wikipedia people, please note, almost all of your crazy equations on all the pages have no reference to them. They have no equation. If you go in a decent book of any kind where they use mathematics like this, they number every equation. And because many of your equations, things like this one, okay, I can't even highlight it here. Okay, that one, okay, this one is used thousands of times across Wikipedia. It's the same form for the same reason. It just says we're naming something in here, according to the derivative. So it's the first derivative of phi with respect to r sub I. So and this one is even here. They say so. And many other things like this. Okay, a common thing, a three-dimensional integral. So an integral of, it's actually a triple integral, or depending on how you do it, do you do your integral in circle coordinates or cylindrical coordinates, or trapezoidal monkey coordinates? I don't care what they're called or what they are, as long as they work. Okay. If they're lossless and you can go forward and backwards in them, then you can do anything you want to. So, all right. So, but I don't know. I can take a copy of Wikipedia and do this myself, but I mean the burden and the time and the computer needed and just the sheer effort is horrendous. But it's a systemic issue. All the equations need to be in symbolic form. That if you have something, this is a potential, and it's probably in volts. But the SI unit for potential that I use is joules per kilogram. Now volts can be converted into that, and so you just do it. A volt is generally measured between two places, but when you measure it with respect to a position, that position has a finite size. There is no such thing as a point estimate. You can have a picometer sized point, but it's still a picometer. You can have an attometer sized point, but it's still a point. It's still a finite size. Now, if you want to go down to the Planck scale, that's fine, but there is no such, in my world, to make all the pieces fit, there is no such thing as zero. Okay, there is no zero R. There's always something there, and you just say how small it is, or how just give a number and put a prefix on it. It's always in meters. You share in SI units, you share in meters, you share in joules, kilograms, the standard things, and you put the prefixes on it. And there. But all the equations, so if I go in and find all the places on here where they talk about potential, there's going to be the same equation again. And it should not be in there 50 or 100 or 1,000 times, okay? All treated separately. They should be connected. Now, is that a lot of trouble? Yes, it is. Is that a lot of trouble relative to the number of replications of use of it by the whole human species for the next 1,000 years? Yeah, you get what I'm saying. So that's what I'm trying to address. We're the the mechanism we have called the internet now, and the way it's laid out, and the way it's put together, and the way people act, is putting a burden on everybody. It's, in my estimate, I've been at this 23 years trying to get a good handle on how bad it is. It's about 250 times worse than it ought to be. That may seem like an arbitrary number, but I keep kind of getting a handle on it. It means that for everything that we do now, it takes a work year to do something that ought to be able to be done in a day across the board. And most of it is in little stuff like this. You have an equation that's not an equation, it's just an image. You have, because you can't calculate with it, you have no reference for it, it isn't tied to anything. This has no link, this has no hover. But in fact, that should hover and go to the archetype of that equation. This is a simple volume integral of a field that is a value at every point measured, multiplied by another value at every point. That's it. It's there. And it's shown as an integral because if you do the original integral stuff, you make your tiny little voxels smaller and smaller. Now, I found mistakes in here. Okay, some of the stuff where they build integrals, they actually leave off. They base it on essentially a value judgment of what to leave off. They say second order stuff doesn't matter. We'll just leave it that way, and we can represent it as this simplified version. And that's all over the internet. That's all over in papers and books and everything else. If it's on the internet, as the director of the Internet Foundation trying to set standards for the whole internet, I'm kind of saying you really ought to do it the right way. So this is not bad here in a sense. Okay, what it's saying is it's saying that you have a base value and with tiny variations, and you can they're represented by a multiplication of two fields. So they're saying, look, there are two things going on in here, each one completely independent, and the multiple, at every single volume element, you multiply one times the other, and my constraint will be that it all has to add up to some constant. Okay, that's what they did. Now, in the world it is now, that constant varies in time, and because of sensor time, finite time of flight for light and gravity and things like that, and acoustics, it almost always has delayed things. So this is just a very, very simple approximation. But you can put a number here. What I would do is hover it. Okay, I'd take every equation on the internet, literally, but particularly start maybe with Wikipedia. Find every equation, and then there should be a nice editor. And if you want to drop it in here, then do it. And it should be like, if you have real fields, like say you have a magnetic an electric field, you could take the energy densities for each of those and say, look, I'm going to say how they interact. I can't come up with a good example right off hand, but basically we could run some real numbers through here. Okay. I picked something, maybe it's not that. I won't go into this crazy notation. Basically, these are also types of integrals. They're just saying, you can represent it this way. I don't like a lot of this, partly because almost every one of these is an approximation. One of the reasons I've been looking at this is because when so many people depend on things like the quadratic Stark effect, and when you go trace it out, they're all having trouble because all you got is approximations. Okay, and the equations are written out like this, so you can't just share them. I can't send somebody this and have it compile and run. Okay, we don't have that capability on the internet now. Now, I'm certain if I go look, there's a few 10,000 people who do it routinely, because they got the special tools and they wrote it themselves and they got it to work and it helps them, but it doesn't help anybody else. Okay, partly because what they wrote is probably very, eclectic and esoteric and kludgy and or it might be the best tool in the world, but because nobody can get to it, or and it doesn't work on the browser, which is all that we have on the internet as a common standard at the moment there. Now, I don't know. Google doesn't pay its. I'm not going to get into Google internal. Google, I'm using a browser here, could very well have a symbolic mathematics tool in here. It could have a nice editor in here. When I go to compose an email, I could use a email component editor with all the good bells and whistles, not bloated, not advertised loaded, not run by 50,000 individual people at Google all doing their own thing, but open so that so they can do. But right now, there's not an easy way. Google does its own thing. It doesn't listen to anybody else. Okay, they don't. Anyway. So all the other browsers, everybody, everybody's just struggling, I guess. What I would like is some components in here. Well, for the graphs here, this is a Rydberg level spectrum. Okay, so I know that I can go in there. Let's take a look at the Rydberg stuff. Okay, so we've got some equations here. F equals ma. You should be able to cover that, and then it says force, newtons, kilogram meters per second squared, m, mass, kilograms, a, acceleration, meters per second squared, newtons per kilogram, joules per kilogram meter, that kind of thing, joules per kilogram per meter. K has these specific values. You shouldn't have to go look down here. You should be able to point to it in the equation and see the details. This mv squared, each one. I would say that you need to also, because I've been over every single possible thing, people use F equals ma down at the picometer level. People use F equals ma at the whole universe level, okay? And you need the proper units for it. So you might, gigatera parsecs or whatever you're going to need out there, or pico atometers or something, whatever you want to call it. I'm really joking a little bit, but basically there are ways to express the size of things. And anyway, so and again, F equals ma shows up on here, and there's not an equation for it, but that one is probably used. Just the F equals ma part of it, probably, just like E equals mc squared, probably shows up 50,000 times on Wikipedia and on the internet, tens of millions or hundreds of millions of times. Maybe not hundreds, tens of millions. And it's that fundamental, but no, it's not all brought together. So somebody writes a page, in here, well, this person writes it and that person writes it, and they write it from memory. They write it, with a little bit of time here and there. But if the people, you do not have to make it bloated. You do not have to make it complex. You do not have to make it elaborate and complex sounding. Okay, that's what usually happens. People say, "Oh, I want to look good, so I'm going to make this more complicated." I'm sorry, that's the human shortcoming. I see the word shortcoming. That is the human shortcoming that has a lot to do with the elaborateness and convoluted nature of much that's on the internet. It doesn't have to be that complicated. Most of it is duplication. mv squared over r, the centrifugal acceleration, is equal to the Coulomb force. Okay, it's said everywhere. I can tell you. I say Coulomb I know the names of most things. Coulomb, centrifugal. Okay, those two terms show up 874,000 times. Okay, and that's about probably around 100,000 authors out there, and who talked about it that way. And there's more of them. There's a lot more of them out there. So every one of the 25,000 universities and hundreds of thousands of, technical schools and colleges and private schools and things out there. There's all the places of learning, and each of the people out there is repeating the same thing. And they're taking their version of it, they're throwing it on the internet, and what I'm left with is this giant bag of duplicates and nobody working together. Everybody says, "Well, I did it. I did a good job." Yes, they did a good job, sometimes an outstanding job. But for the whole of the internet, when somebody wants to go learn Coulomb's law, they're met with 800,000 places. Okay, now it's worse than that, because God, this is probably not even going to work. Coulomb practice problem. Somebody in Google, just on their own, just went out and did this. Nobody asked them to. There's no. You can share it, but you have no feedback on this. You can't say, "Look, you're going out there and messing up my page. I'm trying to do a search, and you're throwing all this other stuff." Do you have the authority to do that? Are you really speaking for the whole world when you do that? Where's the peer review? There is no peer review for anything Google does. Okay, it's a public service. It has a global social responsibility because of what it's doing. Okay, and it can't just go and arbitrarily do that. You can say view more. It says view more. What are they doing? They're taking content out of Wikipedia from an author who's untraceable. They didn't give the author credit, and they didn't give them any responsibility because you can't name them. The information is in Wikipedia for Google to go and look, okay, to find who were the authors of that. This is not really the most concise way to do this, and you didn't put any quantitative stuff. You didn't give the value of K, you didn't give the units for Q, you didn't give the units for R, If you're going to do something there, let's see what they calculate. Okay, now they're just throwing you out to somebody else. So they didn't provide one themselves. They didn't actually add value to this. They just gave you a list. And more than that, they give you a list of about 800,000 of these things. Oh, but they won't show you. How many will they show you? Okay, let's go 10. Okay. Let's pull that. And it's always at the bottom. Come on, people. 14. Okay. So, any more? 18. Come on. How many are you going to give me? 20. Come on, people. Don't make me. Why don't they have it at the top? Again, no feedback on Google. It stops at 20. Okay. They say more than that, but you do it again and maybe you get 25 or something. So out of it now, okay, well now what it is, they said Coulomb's law, and they said 800,000, which I believe is approximately the truth out there. I think there are that many people out there. Okay? When you go look, it has to be. Every high school teaches Coulomb's law. Every grade school, probably, many of them probably mention it. Okay, I think I learned stuff I think I was learning stuff in the 4th grade. So all the colleges and universities, all of the people, it's that many out there, but Google says, well, no, we don't have any responsibility to give the whole of anything. So me, for 23 years, I've been trying to look at the whole of things like Coulomb's law, and I see 800,000, but I'm only given that many. Okay, I have to write my own web crawler to go out and find out if Google's doing it in the truth. Okay? Now, it shouldn't be that hard. Okay? And the people who throw things onto the search pages and say, here's the truth, they shouldn't be there without some validation, without checking. Okay? There are 100,000 people who are way better at physics than I am. Okay? There are lots of people in the world who do it full time, who teach high school physics and college physics, and who took it and did it much better than I did, and they could all check those things. And I'm sure we could get somebody to pay for, donate to support the people who are trying to do that. That's all right. All right, let me get off of there. All right, that's why I'm doing this. These are cool, okay? And the thing is that's pretty clunky. Let me see if I can do. It's probably died by now. Orbitron. Okay. Or oh no, there it is. Okay. Now I think they killed this. No, there they are. Let's get the 4F version. Is it going to blow up? It's not finished. What they do. 5F. Is this any of this going to work? There. Okay. Okay. So these things here. Somebody went and took the time to do this. Now, in the real world, they never quite look like that. Let's see if they have one. They should have coming soon. They never finished it. Somebody started on this. It's at 100%, but it doesn't scale very well. Okay, let's see. So these are the Schrodinger equation is the solution of the 3D wave equation. Okay, so and what happens? It's for a fixed point in space, so an infinite mass point, and an electron. That's roughly the starting point for it. The other way would be basically a almost zero mass, or basically a zero mass charge element, and a finite mass fixed positive particle. And when you perturb it, you hit it in various ways, it will take on these states. Okay, and so these visualizations are aiming at trying to guess at the probability of a charge being there. So it's a field equation, and it's to show you how much charge is at each point there, how much, and what is charge? Charge. What are the units of charge? They're joules per coulomb. A volt is a joule per coulomb. Okay, so it's energy per unit number. Okay, you have actually have. Oh man, let me just. So what I'm trying to aim at here is these things get used all over. I was looking at a group yesterday in Israel, and they're trying to fund some fundamental research. And one of the things they wanted to research was showing that there are equivalent methods for solving models of molecules, okay? And the same methods should be applied to nuclei. Well, I ran across, I was going to say Schwinger, but John Wheeler, okay? John Archibald Wheeler, and he wrote about that back in the 30s. And he said, look, we ought to be able to take the inside the nucleus itself. So down at the center, this smaller than you can see would be the nucleus, right? And this is all the electron doing its thing. And so it has its patterns based on basically the properties of space and the properties of the forces involved in here. And down at the dinky, tiny center of this thing, smaller than I can point at almost, is the nucleus. And inside the nucleus, it kind of does the same thing. I have read stuff about that for almost 50 years, and I've seen every method and every discussion and every kind of visualization you can imagine. So what could you do? Well, you can basically solve the same, basically, it's still the wave equation. Okay, it's still the Schrodinger solutions, but now it's nonlinear because the properties of the vacuum change substantially when the energy density changes. And so you can, when you go to relativistic speeds, you have to make corrections and that ultimately depends on the properties of the vacuum itself. And actually, I won't get into it. But yes, you can. So you can get a set of equations, and let's see, Schrodinger equation. I was doing something else here. Let's see, Schrodinger. Okay, there's more equations. Particles in magnetic field, motion of a charged particle. I can remember. That I think it's really, but basically, yes, you do need to include so here's the Paul. So here, these are more symbols, but the implicit in here is how do you get a calculation out of that? What I'd like to do there, and here, okay, Pauli's equation. Where's the damn number? That's a universal Pauli equation. Okay, there's only one of them. Now, if you have 10 variations of what people like to see, you can just put them all in there and say, choose the one you want to look at. But it has to be one. There has to be an equivalent between them. And if there's missing pieces, you have to show what's missing. Okay? Now, I know that's not impossible. It's tedious, but it's not hard. It just takes people working together. And it can start with, let's get everybody in the world who works on the Pauli equation and get them to work together. So you're Pauli, and have one version of it. What are they working for? So it shows 28,000 there. I believe that to be approximately true. I've used Google a long time. I've done a bunch of searches. I believe that they are doing, that indeed is probably around 28,700 entry points on the thing. I think there might be multiple entries on one page. Why I say entry point, not pages. And it's not pages either, it's documents. So there, how many, maybe there's 10,000 entry pages that you can reach on the internet. And among those, there might be about 30,000 entries for Pauli equation, that exact expression. So, but all of those people should be working together. So let's see. Now the Pauli equation was for, it says spin 1/2. You have to remember that spin 1/2 relates to the magnetic dipole moment of particles. Okay, it has SI units, and you should not use partial names, partial descriptions. Okay, you have to give the whole of the properties that you're working with. Then the things will begin to fall apart. The problems begin to fall apart, and you can do speed of light. What is the speed of it? It says it there. I can't hover in there and go deeper. Google, get on it, please, and put hovers in there. Preview the page itself. You can focus on just one area of the page. You could say, look, I want the hover to refer to that other page and to center itself and put the focal point at this location in there and show that as the beginning point for the hover. And if I click on it, it would go directly there. You get what I'm saying? So I'm saying we need the ability to preview the pages related to topics on any page. So if you come in and say spin, it shouldn't be that. It should be the page on spin. You say that, it should not be that diagram, but the whole page on that. Look at the whole page. The whole page is this, looks like this, and it's got that. What did they put in here? They put in one cute little diagram. This is done on the internet all the time. People put a flag to indicate a thing. They put in a symbol to indicate a thing, and that's nice and convenient for a human with a finite memory and maybe not enough time to go do it. But if we change it so that you can go to this page, say, I want to create a hover link based on this, and basically you highlight it. and then you say, I want to add that hover link in here to this. Let's see, relativistic effects. That's actually done in Wikipedia. It's also done on the internet. How many times? Let's go look. It's done there. 950, about 1 million times. Okay, so, and it's actually worse than that, because actually you say relativistic effects, effect, or you have to get a bunch of them. If you don't put the quotes on there, Google throws anything they want to on you, and they can game it like crazy. So you try to put the, oh, sorry, I did. What did I do? I got into bookmarks. I hit a thing. Or, well, I'm not sure. I've never, I don't. You can do much better things. So, okay, millions of times. Okay, tens of millions of times. Okay, it's a very broad thing. At one time, everybody on the planet had probably got told about Einstein doing relativity, and it got into every single part of the human society. Unfortunately, it also got stuck in on the internet in tens of millions of places, in every different kind of way. And turned out, what was a fairly simple and well-focused concept and a useful tool now has gotten out to where, you could spend your entire lifetime just going to find the pieces of it and the ramifications of it. Not that they've made any progress on many of those. Many of them are repeating the, relativity 101, physics 101, high school introduction to, physics that mentions relativity things, and it's all down at this real low level, and it doesn't build. It can't build because there are too many pieces, too many people working on small parts of it, too many false leads, too many incomplete pictures, too many incompatible descriptions, and not even mentioning that the same thing can be said in hundreds of different human languages on the planet. And anyway, now those are all things. It's duplication, variation, false leads, unidentified authors, untraceable facts, quote facts, untraceable really wonderful things that could be done that you can't find out where it came from, or you don't have enough information to resolve it. So I went through physics, so I'm using a lot of those examples. But let's take a look again here. So here, let's go down. So this is cute. We've got one dinky little program. You got a graph. None of these things here. This is used until this factor in here, that portion of it is repeated all over the internet tens of millions of times. And yet it's not labeled and tied to those. Okay? If you did label it, if you hover the equations and basically have an internet browser capability for tracking, those kinds of things, then you could do it. Not coming to text, but going to quantitative calculations, standard fundamental constants, reference data sets, calibration data sets, classic experiments and determinations. There's a huge amount of stuff out there, and it's not organized. So, yes, I know the internet was built for TikTok, and I know that it was intended so that people can find old Michael Jackson albums, or share. I'm not going to minimize any of that. I see all parts of it, and there isn't a single human being on the planet that doesn't have value. But those things are hard. Okay, what's the social value of TikTok? It actually has taught and changed society, and I don't know that the consequences of it are settled yet. Okay. Well, anyway, maybe I'm a belabor. These things I see again. So the Bohr atom is in there. So here it is on somebody wrote it in. Well, I'm writing about relativistic quantum chemistry. What do I know? Well, I'm going to repeat the Bohr model, and I learned a bunch about it, so I'm going to shove it in here and do it again and again and again and again. Let's see if we can see the site. Wikipedia or let's see, what did they put in there? Something relativistics. They did Schrodinger. They threw in all the basic things that you always refer to. The Bohr model. Bohr. 6,000 times. Now, all those 6,000 times just on Wikipedia should be one coherent thing. Bohr model should, you should be able to start there and hover to every single part of that. And any reference to the parts that are common, that are exactly the same, need to be linked in a map, a hoverable map of that knowledge, so that you can get to every single part of it. Okay? If I go in there and look at Rutherford Bohr, which is basically the context of Rutherford and Bohr time and the implications of that, I might go in and get into histories and all kinds of other things, but that should be there in a single thing. My picture of the universe, of history, of all the things, is only one. It is one picture. Okay, it is not tens or hundreds of millions of copies of things. Okay, the internet is representing the individual views of the 7.8 billion people on the planet, plus a lot of them who died that probably contributed things that are on the internet now. And we don't need that many. Now, I say if you don't simplify by throwing things away. So you go in and you don't go in and say, well, I want to say there's only one Bohr model. It's got to be mine. And somebody says, well, good. Now I've got the central Bohr model, and I'm going to milk it for everything it is. I'm going to extort huge rents for it. I'm going to extort everything I can from it. That's the usual human behavior on the internet for anything that gets centralized. Now the open models are meant to balance that. So you say, okay, we have knowledge that's getting shared. We're not going to let anybody game it. Now Wikipedia, I've already met some of the people who build their territory and guard it fiercely. And what you need to do is to have a way for, if you need to, 10 million or 100 million or a billion people to all contribute to one thing and not have them, not lose anything. You can do that. Part of it is kind of a rough thing that the machine intelligence guys really hadn't really spent the time on. They talk about it, they play at it, but they don't really go out and do it. Okay? What we need to do, if you say Bohr model on the internet, okay, let's do that. If you say Bohr model on the internet, we're up there. Okay, that's the specific thing, and it's also said in different languages. So maybe, like I say, every chemistry class in the world, again, remember about 25,000 regular universities, colleges and things. So there's at least that many places where they teach it. And I know that it's taught in books and in in high schools and probably in grade schools now. So, yet there's only a finite, the actual equations are there. When I see them exactly replicated, so you go in there, I'll show you what I'm talking about. You go down there and you see the usual pieces of it. Let's see, where did they go? This one, the in lambda, it says that you get a finite, an integer that in stable situations, essentially dynamic equilibrium situations, you're going to find a resonance in only an integer number of wavelengths fit on a circular orbit. But in fact, the orbits are not circular in that sense, or so there's more to it than that. Okay, so even though they put some of this stuff and it's out there, now they keep doing anyway. So these things here, your centrifugal force equals the Coulomb force, the usual thing. You solve that, express it that way. See, where did they get to? They're going down, do that, they repeat it, alternate, and you reduce mass. You have to allow that the masses are not infinite for the proton, or this transitions between levels. Okay, well, they didn't even put it in here. Okay, so the useful stuff to actually calculate the levels, they didn't put in here. This stuff, they talked about what it was. They used words for it. They put equations you cannot use, and they didn't do a single calculation. You can't go in here and there are the fine structure constant. Don't do this. That there's an exact number. Alpha, the fine structure constant, 1 over 137 point whatever the rest of it is. I can't remember. You can go to the CODATA reference there if CODATA were actually built so the whole internet could refer to it. Not as a stumbling block. It can be cached. It's just that when you go to trace it out, it ends up at one place. There's only one best current estimate for certain types of problems for that. Okay? Now I know what can happen is you get 2 or 3 or a dozen large areas of research that haven't consolidated yet, and each one has their own value. And so you end up with islands that are close but not exact. And so they each need their own version of that where it's internally consistent within their group. You leave it that way, and then eventually you go on and you see if there's reason. Yeah, it might be really good reasons, maybe a missing term or an experiment that you need to do or something, and then you can do it. But it should be not. It should not be 500,000 references to fine structure constant, probably with a handwritten version of it in each of those locations. That should be one small network of those where a finite number, I'm talking not more than a dozen or so, of the best values for each of the disciplines and areas where that's important there, to have that, and not in some group that uses it to create a monopoly. Okay, so if you own a constant like that, or if you're going to serve something like a fine structure constant for the whole internet, you have greater responsibility to everybody. Basically, everybody on the planet can come to you and say, you need to be open. So those sorts of things. This is human organizational behavior. Is most of the 23 years I've spent single-mindedly looking at the internet and its policies and methods and all values and purposes. Those things need to be dealt with. So if you have Google is misusing its social responsibility in here. It was given a virtual monopoly on a certain type of search. And there are many parts of things that they haven't done, are not doing, and it's probably hurting society as a whole. So it is hurting society as a whole. I just can't do anything about it. Okay, I'm not even sure I want to say it here because, it's they why waste my time on things I can't change, right? Okay, well, these things here, this is actually not quite true. Okay, if the gravitational field changes, the values of the vacuum permittivity, the magnetic permeability of the vacuum change. The vacuum property changes when the gravitational field changes. Okay, that's the best cut on what all is out there on the internet now, okay? And which means that you need to put a relative dielectric constant in here, and not just one constant. It has to be frequency dependent. So even though this looks like this ought to cover all frequencies and energies involved, it actually doesn't. Okay? Some of that is just because all the different fields where they are working at, if you're working in terahertz, you're just struggling just to get that small band of, a few powers of 10 frequency range to work and do whatever it is you're trying to do. Most people who work and use things in the world are just trying to make things better, trying to make them work. And the theory is chasing after them. Now, much of the theory is embedded in these kinds of things, and it's scattered all over the internet, and it's scattered in hundreds of thousands, millions of individual authors not working together. So I can say the same thing. I look at some of these. These are fairly easy. You say, fundamental constants, fine structure constant, these things. The standard model, gosh, I'm going through that. If you talk about obscure and untraceable and everybody saying their own thing, there's a case for it. Now, they say it's a homogeneous and complete thing, but is there anybody running it? And is the model of showing all the interrelationships between the constants that are involved there and the methods that they're using to do the calculations, is that open, traceable, auditable, lossless? Those are the kinds of things that need to be applied to those groups. And you can't just come out and say, well, we're the biggest and the best because we have a model that's supposed to handle the whole universe, and you should listen to us. That's great if you're trying to get funds, and it's great if you're trying to persuade people to give you a bunch of money to go spend that and never share the results from it, okay? Which is what's happening on the internet. Okay, it's changing a little bit. Okay, Large Hadron Collider, they spent a bunch of public money. It wasn't theirs. Okay, it wasn't like a group went and raised the money themselves. The governments paid for it, and ultimately people in different countries paid for it. And is that information going back out to help everybody? Not really. And that's measurable. You can go and trace out what are the impacts and who's using what. The nice thing is the internet is open enough that you can trace most of those things. I've spent couple of decades just going and trying those kinds of things. Do I care if some group, builds a monopoly on a certain set of ideas and things and milks it to enrich themselves? It happens every day. I can't change human nature. But what I can say is that if you're going to have a model, that on the internet, the rule is it has to be open, auditable, traceable, verifiable, and it has to be in a convenient enough form for doing that you're not basically, keeping things secret just because you're holding all the pieces. Okay, you say, oh, you can test our model, but you can't run this piece of it. Okay, or you can do this. Now, some of that's human nature because a lot of the pieces are described as being perfect, and then they're not. Okay, much of what I do, I'm giving you the best cut I can on what I'm thinking at the moment, but it's so frail and incomplete and everything else. One dinky little person spending even if I try to work, 100 to 120 hours a week, 7 days a week, there just to say, I've done a conscientious, decent job of looking. Okay? But my brain is finite, and my time and energy is finite. That's how, as many of these things as I've looked at, how many things do I look at? Okay, well, that's just a little piece I just started on. This is some of the current ones. Okay, so these are the kinds of topics that I go and look at and trace out there. So that's not much. Okay, I keep saying I need to do more on neutrinos. I do, so I spend a long afternoon or a couple of days, and I say, let me look at neutrino scattering. Let me look at neutrinos again, and then I go, then here's beta decay. So, okay, here, transmission. There are wonderful opportunities to improve the efficiency of cable transmission, of electricity and signals all over the whole planet. Not only for the big rich countries that are already moving a lot of stuff, but for the countries that are just getting into it. I wanted China not to build more roads when they were starting, and I wish I hadn't had any say in it. I would have said, invest in communications and virtual organizations, so at least the education, research, make it virtual right from the beginning, and it could have saved a lot of time. You wouldn't. Now, I don't know. There are other issues. They built huge cities. I don't know. They didn't ask me. Oh man. All right. So this is cool. Let's just do this. Now I've insulted everybody. Okay. Let's see what I can do. Let's see. Is this going? Okay. Well, look how crude that is. Okay. But I think it has the potential to work. What have I done? Programmatically, I generated the symbols. Human-wise, I can say, well, I want it here, and I want that. I want to spread this out like that. Okay, that's the way I want to see it, right? Or, see, oh, here. Oh, that did work. Okay, so I can do that, and, then come clip it. Where's my clipper? Okay. So I could go there, and in principle, I could do that in such a way that with a few tools, I can grab the equation. I can say now, in here, well, now turn off the red, turn off the blue, take the equation, and have these traceable. So, okay, where'd my map? It disappears in here inside this clipper thing. So I only see a teensy tiny little dot, 1 pixel big. That's why I couldn't see it. I don't have any way to change it. It's Windows. It's, back in dinosaur days, they made it, and you can't change it. You can't trace all the pieces and say, where's the development community for snipping tool? Okay? There isn't one. No, there is one. They just can't work together because there's no way to trace the users, for the users to talk to the developers. Every piece of software on my computer, you pretty well can't, if you find a bug in it, you can't report it because it only gets reported back to the main organization, not to the specific people and groups that are responsible for it. So the responsibility for everything, if I write this equation and it gets out somewhere, it should be traceable to me or to somebody who's willing to take the responsibility for it. Do you get what I'm saying? Okay, so all right, they're doing it. I think I've covered about everything I can here. So let's just look at this again. Okay, so In JavaScript, this is not impossible. I'm not using anything there. I had to use this crazy SVG stuff, okay, which is not integrated with HTML. Now that is possible to resolve that, okay. And what is it? Much of it was, what? I'll show you something. Okay, okay. I put a movable. I put a logic in there so that I could move my boxes. Okay, I can move these boxes because I grabbed the top 10 pixels of it. It checks. But when SVG came in here, it took that action, that event listener for the mouse, and it applied it to the whole of the red area. Let me see if I can get, yeah, nope, not there, not there. Yeah. So basically it extended it down 10 more pixels. Okay, that's what it looks like. Okay, so here it's not moving there. So it should only be the top 10 pixels of the blue, but it did 10 more pixels for the red as well. So I put an SVG. Now why did it get offset like that? I don't know. It shouldn't be, but that's there. Now maybe I've got something wrong in here. You know, maybe I need to play some more games and things. I don't want to put my whole life on SVG. It's too big a community, and there's nobody responsible for it. Okay, it's not even corporations, you can't bring them to task. So it used to be somebody would build a widget, and you would say, oh, go to the widget manufacturer, and you say, oh, it's not working, or you know. The software industry makes more money when they make it more complex and broken, because then the customers have to come to them, and what do? They say, buy our bigger, better version, because you know that's just a toy. You get what I'm saying? So I see every human foible, every organization foible on there. Anyway, I'm getting there slowly. So I got my cute little movable box, okay? And it has the qualities I want. It's resizable. These boxes aren't. Okay, I just made those separate there. But ultimately, I want these to go in here, okay? And then for that to be movable, okay? So I want to like drag it into here. So, and nobody helps me. Oh, poor me. Okay, well, let me short. You know what I was doing? I was counting I want to count all the words on the internet. Now, that may sound bizarre and strange thing to do. There are groups that actually, there's some wonderful work on corpus development that's going on, and they try to get much of the public internet that's in fairly usable form, fairly decent stuff, and study the use of language in there. I'd like to go further, study the use of equations in parts of language. I have done this with part of what I was looking at was GitHub. Okay, site, GitHub. I keep going back to this. It says there's 64 million entry points on that. That's probably not out of range. When I've gone to test, somewhere an organization does have a complete map, a site map, which is a listing of all the pages on all the URLs on their site. I've matched them up reasonably well, so it's not out of reason, and I understand the issues of scanning. I've built a lot of scanners, particularly 20 years ago when I first started. Then I said, it's gotten too complex to use that. So there are these things out there, and each one of these, if you go to any one of the, what they call repositories or packages or projects in here, you get these. So these are the pinned ones. Let's just look at one of these, web framework. Okay, So I don't even know what this one does. I'll have to see. But I can look at the whole of it, and it doesn't say. One of the things it doesn't have in here is how big is it. So these are folders, just like a directories on a disk drive. In fact, this is identically a copy of somebody's disk drive in a sense. That's roughly what they've done, is they transferred file manager types of things, or LS, or whatever, the directory structures that are out there, the oldest technologies on the internet almost, throw it in a folder, throw it in a subfolder. And so we're stuck with that, and then the human has to go in, read them, remember was that in the docs folder, was that in there? There's no search in here. You can't search for a file in here. You can't search the contents of the files in here. You can't do any profiling or extraction from all of them. Say, show me a list of all the functions in here. I don't even notice it's scripts. Okay? Well, that's Python, and that's a shell script. Okay, so somebody wrote in those two languages. Test scripts. So I don't know what they mean. HTML probably has some JavaScript in it. Let's see. There's some JavaScript. So I'm trying to get the people are getting eaten alive on using software development, because they're still throwing things into directories and in files and in long ASCII encoded, human readable, human handwritten things. Okay, there are much better ways to do it, and I'm talking a factor of 100-fold or 200-fold or 1,000-fold different in speed of getting things done. If you look at the management complexity of even a moderate size project on GitHub, it's a huge corporation would quail. Okay. And people just routinely go in there and say, well, we can do it. And they basically do it by not counting the value of anybody's time. So this is open, and everybody's working for free, or they're getting paid by a company and they do whatever they have time for. Yeah. But ultimately these things need to be tied to some things. The value of human time of the users is one thing I use all the time. I say, I count. It does matter what time the user spent. You might say, well, this high school student, I don't care about them, or I don't care about the 3 million of them that are just graduating, I think, in the U.S. I don't care about any of those. All those, no matter what they do, whatever software they're using, I don't care about their time. Well, anyway, this gets back to, I hope I can figure out a way to get all the equations on the internet and get them so that they're all to me, I treat it like a giant algebraic equation. Okay, you have all those terms in this giant expression called the internet, and and some of the terms are, is this equation identical? Okay, is this thing? So wherever I do, let's see, this SVG, see if there's somebody stars. I don't know if I was doing something else. I'm doing a lot of stuff on videos. I guess I don't have any flash memory. Oh, these guys ought to have. Probably this research. There, okay, this is a. Okay. This one, let's see what they look. This is should be a pretty straightforward. Yeah, usual. Stuck in here. What other thing? I should be able to have a database of all these people and know how to do it, and be able to refer to it from this context, not have it. I have to a human read it. This is only paper on here, so all this stuff in here. Okay, the power radiated by a quark undergoing circular motion. Well, that's kind of an interesting thing. Okay, but power is in watts, and the intensity of that, watts per square meter, scaled down to femtometers, picometers, femtometers, down, attometers. They're down, as small as you want to go. Anyway, so let's see if they, okay, so that that's a thing. G squared has actual values in there, and there is a literature out there, and it might be referred to here. These dinky little equations they have in here, they're trying to use a few symbols to represent very complex measurements. There's the usual relativistic correction. Okay, there's that 1 over 1 minus v squared thing, and it's in units. It should be c over the sum of c squared minus v squared, and do it in absolute units. Okay, so somebody's non-zero temperature. The Hagedorn temperature is down there for quart boiling point. I think it's roughly that, or melting point. You could say it either way, where it acts as a coherent liquid with a surface tension and will ramificate and break just like droplets of water or spray, things of that nature. But all of these equations and methods in here have mathematical language. And see what they're doing? If some of this got transcribed into Wikipedia, if Wikipedia referred to it, you would like to be able to say, I want to refer to that equation in here. Okay, not just to the whole paper and say, okay, this is a really important paper, 50,000 people are reading it, and every one of them I send a link and they have to go read it, scroll down, read the whole thing, and get down to this point. How many eyeball inches do they have to use? How much brain power do they have to use just to get down to the proper place when the person reading it or referring to it has a specific equation in mind, and knows it, knows where it is. So, if we could come in here and say, look, I have this. Remember what I was saying? I can't do it. I don't have a thing to draw a box. Maybe I do. Let me see if I have one. So I'll use this one. I'm going to use this and say, oh, I missed it. There. Oh, come on. It really didn't want to. There we go. What's happening is I think it's conflicting that even though I'm on the mouse is getting eaten up by the PDF viewer thing. Okay, so I would like to be able to say, take this area and make a link to this area that I can use and refer to in my paper or in some other context. Do you get what I'm saying? So, likewise. Okay, I'm going to see if I can move this. Okay. Oh, it's not. It really is doggy. Okay, I come over here and say, look, I want to refer to this thing here, and then have it refer to. I want a link to this outline in this paper. That's technically possible. More than that, you see this thing here is text, but it's not in a transportable symbolic mathematic form. I can't throw this in and do calculations with it. I can't take these two equations, that one and that one, which have common terms. There's a v here, there's a v there. I should be able to say solve for v, or take, you could solve for v in this equation, shove it in here. You get, link these two. Now maybe you do it by iterative process, a solver, a constraint optimization. There are so many methods for doing that. So you get one. So I'd like to take all the stuff out of PDF, but so many PDFs on the internet. If you go look at them, you'll see a table, and it was hand built. The secretary or somebody volunteered and they typed it in. It wasn't built as it wasn't built as data and these things. So anyway, I see all these things. This one, okay. So we're missing a lot of opportunities, mostly because the skill it takes just to take, for me to go just read this paper and just transcribe this and test what they've said in here. If I have to hand transcribe that, if I have to do it on paper, it's a horrible thing. If I can get it into a symbolic math tool, that's a little bit better. But why should I do that? If I have to spend hours or days or weeks to unravel this thing here, however long, depending on my skill. Think of all, if this were to be a good paper, and thousands or fifties of thousands or millions of people might want to come refer to it at some point, then how do we do that? So I'm reading this in the background. What they're doing is not outrageous, and some of it could be useful. Much of it is basic stuff that everybody does. Okay, there's only a toolkit. You go and take physics, even at the highest levels, and it's based on really fundamental pieces, and they get repeated and repeated and repeated. Everybody's trying to get their version of it that works for what they're trying to do, and sometimes they're hoping, if I just keep mushing this around, something's going to fall out. So let's see, what did they cut away? What am I doing? Plots energy density, strong coupling, quark. Did they actually get high frequency gravitational radiation out of this? Did they understand that the vacuum itself, when it compresses, is a transmission of a gravitational signal? That it changes the speed of light, it changes the rate of clocks when you do that. Okay, well, what I just rattled off, I know to be true, and it doesn't matter to anybody else, but I would like to be able to go in and get things like that, test them myself. I can't ask anybody on the planet, say, well, look, I think this is a good idea, you ought to test it. Nobody's going to do. So what do you do for people who, don't have any resources? Well, most countries in the world don't have resources. Literally, most people in the world don't have many resources. Who even can read a PDF on the internet? You can't read this paper on a cell phone, not easily. You can't even read it on a decent desktop computer. You need and you can't replicate any of this. And what is that? That's not because the people don't have the smarts to do something with it, and probably may understand it even better than what they're doing here. I'm not talking about myself. I'm thinking of certain large countries in the world who have, many millions of people, and high standards for education, wonderful mathematics, and don't have the tools to go in there. And part of it is that if they would learn, if they would share their information, if they write an equation, you have a whole group of 1 billion people, and they all, when they write down, if they're going to refer to Bohr's model, there should be one for their whole country. There should be one for the whole internet. But a country gain a substantial benefit over every other country. If you want to go into, territorial thing and say, well, for our purposes, we want to make more money and build better things. Well, you could do it that way. Okay, there's human society probably won't prevent that. E squared over 3. Yeah, there are lots of similarities. I'm sorry, I got distracted. All right, thanks for listening.